Imagine a world where what feels like AI magic, creating amazing images, writing tricky emails, isn't just for the tech giants anymore.
Right. Or just for the super specialized expert.
Exactly. It's really here for everyone now, and it's happening incredibly fast.
Yeah.
But, behind that magic, there's a really fascinating how, a practical process.
An engineering process that's changing all the time.
And that's what we want to explore today. Look, this isn't going to be some dense technical lecture. Think of it more like a deep insight dialogue, specifically designed for you.
Yeah, absolutely.
Our goal is really to demystify this whole AI revolution. We want to break down the complex stuff into clear, understandable insights, especially if you feel like you have, well, zero technical language when it comes to AI.
That's the key, isn't it? Making it accessible.
Totally. So whether you're prepping for a meeting or maybe just trying to get your head around this fast-moving field, or honestly, if you're just curious, we want to give you a shortcut, a way to be genuinely well-informed.
And what's truly fascinating here, I think, is just how much this new wave of AI has opened things up. It's really democratized access to these incredibly powerful tools.
Yeah.
So we'll be navigating this whole exciting landscape through a deep insight dialogue into Chip Huyen's fantastic book, AI Engineering, Building Applications with Foundation Models. It's really insightful.
It really is.
And this particular dialogue, this deep insight dialogue, is specifically set up to pull out the most important nuggets of knowledge from her work. We want to help you understand the practical side, how AI is actually built and deployed.
And crucially, without needing to know how to code.
Exactly. No coding required to understand the core ideas. It's about getting the mechanisms, the challenges in AI engineering, what it takes to build real applications, and this is vital, how these powerful systems are made reliable and actually useful for you.
That's it, exactly. Our mission here is to give you those aha moments.
Yeah.
The surprising facts, the clear understanding of the core ideas, and the big challenges. The idea is you'll walk away with a really solid mental model of how AI is being built and put out into the world today. And you'll see just how accessible this tech has actually become for pretty much everyone. Okay, let's kick things off by looking at what people are calling the ChatGPT moment. Because it really did feel like a switch just flipped, didn't it?
It absolutely did. Overnight, it seemed.
Yeah. Suddenly, AI wasn't just stuck in research labs. It was like in our homes, our workplaces, changing things almost instantly.
But it's interesting. While that rapid adoption feels sudden, you're right to think it's actually built on decades of work, foundational stuff.
So what actually changed? What made it this global phenomenon so quickly?
That's the million-dollar question, isn't it? It feels like an overnight sensation, but like you said, it's really a culmination of steady progress. The big shift, the really pivotal development is the emergence of these new AI capabilities, specifically generative AI.
Right. The AI that creates things.
Exactly. And that's done two incredibly significant things at the same time. First, it massively boosted the demand for AI apps. I mean, across basically every industry, finance, art, healthcare, customer service, you name it. Everyone suddenly wanted a piece of this AI power.
Okay, increased demand. That makes sense.
But second, and this is maybe the more surprising part given how complex it all seems, it dramatically lowered the barrier to entry for developers.
Lowered it. How?
Well, what used to be strictly the domain of, PhDs working with super complex machine learning models, it's now genuinely accessible. The real game changer is that you can now build pretty sophisticated AI applications for yourself, for small business, whatever, often without writing a single line of traditional code.
Wow.
And that fundamentally transforms AI. It goes from being this niche, specialized academic thing to a universally accessible development tool.
So if I'm getting this right, the key insight here is that AI isn't just a product you buy off the shelf or some complex system only experts can build. It's becoming more like a utility.
That's a great way to put it, like electricity or cloud storage.
Yeah, something you can tap into easily, making it available even to a tiny startup or just someone working on their laptop. That feels like a huge shift.
It is massive.
And the book really digs into this, how the new scale and these new capabilities, especially with what are called foundation models.
The LLMs and LMMs.
Right, the large language models like what powers ChatGPT and the large multimodal models that can understand images and text. These aren't just creating opportunities, they're also bringing a whole new set of engineering challenges.
Absolutely, new problems to solve.
And AI engineering, as Chip Huyen defines it, is really all about adapting these incredibly powerful pre-built models to solve specific real-world problems.
Precisely. And those foundation models, they are absolutely the core building blocks. They're the catalysts behind this AI explosion we're seeing. You can think of them as these incredibly vast, pre-trained neural networks.
Like giant digital brains.
Sort of, yeah. The central idea is that these models, whether they're text-focused LLMs or the multimodal ones like GPT-4V and Claude 3 that handle images too, they're just so massive and capable that they operate on this model as a service principle.
Model as a service. Yeah. What does that mean in practice?
It means they're developed by a really small number of large organizations, the big names, Google, Meta, Microsoft, and over in Asia, Baidu, Tencent.
Tech giants.
Right. Or by these really well-funded startups like OpenAI, Anthropic, Mistral. These companies pour billions of dollars and years of research into creating these foundational layers of intelligence.
Okay.
And once they've built them, they make this huge brain power available to pretty much anyone via APIs.
APIs, those are like the connectors between different software.
Right, exactly. Standardized ways for computer programs to talk to each other. So instead of needing to build your own AI from scratch, which is astronomically expensive and time-consuming.
Billions of dollars, years of work.
Right. You can just essentially rent access to these super brains through an API. It's like having a superpower on demand.
That really levels the playing field. I remember hearing Sam Altman from OpenAI saying something similar, that adapting these models is the biggest opportunity for most people.
He's spot on. This model as a service approach means individuals, small businesses, they can all leverage cutting-edge AI without that absolutely gargantuan upfront investment in hardware, training data, specialized talent, all of that. It's unprecedented, really.
And the applications that are popping up because of this,
Yeah.
it feels like they're everywhere.
It's truly endless. The big insight here is that AI can now automate, or at least partially automate, pretty much any task that relies on communication or processing information.
Any task. That's a bold claim.
Well, nearly any task involving language, images, data. The book gives some amazing real-world examples that show how deeply embedded AI is already becoming. Okay, take writing and communication. AI is being used for everything. Drafting personalized emails, handling complex customer support requests, even summarizing dense legal contracts.
Making legalese understandable. I could use that.
Right. And it's proving especially helpful for people who maybe don't love writing or find certain communication tasks difficult. There's this fascinating bit in the source material.
Yeah.
Workers who got exposed to ChatGPT were apparently twice as likely to report actually using it in their real job just 2 weeks later.
Twice as likely in 2 weeks. That shows how immediately useful people find it.
It really does. And it's not just text, is it? You mentioned the creative side earlier.
Absolutely. Image and video production is seeing a huge revolution.
It really is. And creative tasks, maybe counterintuitively, benefit massively from AI's probabilistic nature. Its ability to generate varied, often surprising, and sometimes incredibly novel results.
We're seeing companies like Midjourney just explode, right?
Yeah. Midjourney, yeah. Reportedly hit $200 million in annual recurring revenue by late 2023. That's staggering for an AI image generator. Then you've got Adobe Firefly built right into Photoshop and Illustrator.
Video tools like Runway, Pika Labs. That Sora model from OpenAI looks insane.
It does. The pace is incredible. Just look at the app stores. As of December 2023, half of the top 10 free graphics and design apps on Apple's App Store had AI in their names.
Half. So it's not just a buzzword anymore.
No, it suggests that soon AI features will just be the default, embedded so seamlessly you won't even need to mention AI. It'll just be expected. We're even seeing stuff like AI-generated headshots for LinkedIn profiles or job applications.
Seriously. AI headshots.
Yeah, it speaks volumes about how quickly it's being accepted and seen as useful, even for professional presentation.
Wow. Okay, so writing, images, video. What about coding?
Huge impact there, too. Tools like GitHub Copilot, basically an AI assistant for programmers, generated $100 million in annual recurring revenue in just 2 years.
$100 million for coding help.
Yep. And it's not just writing code. AI can synthesize training data for other models, help develop new algorithms, and write code itself. It creates this kind of positive feedback loop, potentially leading to even more powerful models down the line.
Okay, that makes sense. What else?
Well, think about workflow automation and information aggregation. AI is brilliant at pulling structured information out of messy, unstructured data.
Like reading a PDF contract and pulling out the key dates and names.
Exactly. Or analyzing credit card statements, financial reports, even getting data out of charts and graphs automatically. Making sense of all that chaotic information is incredibly valuable for businesses.
I can imagine. And education. That feels like a big one, too.
Profound impact, absolutely. Khan Academy, for instance, now has AI teaching assistants offering personalized tutoring.
Personalized learning at scale.
And some teachers are getting creative assigning AI-generated essays for students to critique and correct, turning a potential cheating tool into a learning exercise.
That's clever. But there was that story about Chegg, right? The homework help company.
Oh yeah, very telling. Their share price apparently plummeted like from $28 down to $2 right after ChatGPT took off. Why? Because students started turning to AI for homework help instead.
Wow. But the flip side, the more positive view, is that AI could be this amazing personalized tutor,
Yeah.
right? Helping you learn almost any skill faster.
Exactly. Coding, languages, complex math, and then of course you have conversational bots. They're incredibly versatile.
For finding info, explaining
Charming ideas, even companionship or therapy, apparently. Or emulating specific personalities for fun or specialized help.
It's a huge range. So if we zoom out and connect this to the bigger picture,
Yeah.
what does this mean for jobs for the workforce?
The implications are really substantial. There are studies, like one by Elin Du and others in 2023, that have tried to map out how exposed different jobs are to AI.
Exposure meaning AI could do parts of the job.
Pretty much. They found jobs like interpreters, translators, tax preparers, web designers, writers showed almost 100% exposure.
100%. Does that mean those jobs are disappearing?
Not necessarily replacement, no. It's more that AI-powered software could significantly reduce the time needed to do at least half of their tasks. So it's less about jobs vanishing wholesale and more about a fundamental shift in how many jobs are done.
So increased efficiency, maybe shifting human focus to different kinds of tasks?
That's the likely outcome. Focusing on the uniquely human skills, creativity, critical thinking, empathy, complex strategy, stuff AI isn't good at yet.
So pulling this all together, what does this actually mean for you listening?
It means this explosion in AI capabilities, coupled with that dramatically lower barrier to entry we talked about, it translates into massive opportunities. Opportunities for you to leverage AI, even without deep machine learning expertise.
The focus isn't on building the models anymore.
For most people, no. It's decisively shifted towards effectively adapting and skillfully using the existing powerful models. As Computer World put it, teaching AI to behave is becoming the fastest growing career skill.
Teaching AI to behave, I like that.
And it's worth noting, too, like open source AI engineering tools. They're growing faster than any other software engineering tools out there. That just fuels the fire, making it even more accessible. It's a skill you can learn and apply right now.
Okay, we've talked a lot about what AI can do, but let's try and peel back a layer. How does it actually work? How do these models think? Let's try and simplify this without getting lost in the weeds.
Right. Let's peek behind the curtain.
At their most basic level, especially these large language models, they're really just incredibly sophisticated completion machines, aren't they?
That's the absolute core idea. It sounds simple, but it's powerful. Imagine you start typing a sentence, maybe a famous quote like, to be or not to be.
That is the question.
Exactly. A language model, given that first part as a prompt, its fundamental job is to predict the most probable next word, or sequence of words. In this case, it would very confidently predict, that is the question.
So it's predicting based on probabilities it learned during training.
Precisely. Based on processing just unbelievable amounts of text. But crucially, these are predictions. They're not guaranteed facts, not absolute truths. And this probabilistic nature, this is what makes them both incredibly exciting, allowing for that creativity, and let's be honest, sometimes a bit frustrating because they aren't always perfectly consistent or accurate.
That makes total sense. It's like a superpowered autocomplete. Now, something truly revolutionary about how these models learn. It overcomes this huge bottleneck that traditional AI faced for ages, right? The data bottleneck.
Ah, yes. The labeled data problem.
Yeah. Older models needed tons of expensive, slow-to-get labeled data, like someone had to manually tag every photo as cat or dog. But these new models use something called self-supervision. Can you break that down simply?
Self-supervision is absolutely key to why these models are so big and powerful. The core idea is ingenious. The model basically teaches itself by inferring its own labels directly from the input data.
It labels its own homework.
Kind of. It cleverly overcomes that data labeling bottleneck. Take a simple sentence. I love street food. Instead of needing a human to label anything, the model can create its own training exercises.
How?
It could, say, hide the word love and then try to predict the missing word from I street food. Or it could try to predict the next word, like food, given I love street. It uses the massive, unlabeled text of the internet as its own teacher.
So it's constantly playing fill in the blanks with itself.
Exactly. Millions and millions of times. This self-labeling trick means you don't need armies of humans painstakingly labeling data. The data essentially labels itself. And that fundamental shift allowed developers to use truly massive internet-scale datasets.
Which leads to bigger, more powerful models.
Much bigger, more generalized, and way more powerful models than we ever had before. It's what let them scale from niche tasks to understanding human language in this incredibly broad way.
That's fascinating. It's like a student learning just by predicting the next word in every book they read, and eventually understanding grammar, context, meaning.
That's a good analogy.
And this ties directly back to that probabilistic nature you mentioned. Because they're predicting the most probable word, they don't always give the same answer twice, even for the same input.
Right, which leads to both creativity and unreliability.
Exactly. We see the creativity in things like AI art, but the unreliability when they hallucinate or make stuff up. How does that variability actually work under the hood?
It comes down to something called sampling. If the model always picked the single, absolute most likely next word every time.
Its output would be really predictable and boring.
Very boring, very repetitive, like reading a very dull textbook. So instead, models usually sample from the whole probability distribution of possible next words.
So they consider multiple options.
Yes. Let's say you prompt it with, my favorite color is. And the model calculates that green has a 50% probability, blue has 15%, and red has 30%. A purely greedy model would always pick green.
But a sampling model.
A sampling model won't just pick green every single time. It will pick green roughly 50% of the time, red 30%, and blue 15%. It makes an informed probabilistic choice, not a deterministic one.
Right, so it's like giving the AI a weighted dice roll, not just the single best answer. And isn't there a way to control this randomness? I've heard about temperature.
Yes, temperature. That's the knob, essentially.
The creativity dial.
Exactly. Think of temperature as a way to redistribute those probabilities. If you turn the temperature up, say, to 1.0 or even higher, it makes the probability distribution flatter. It reduces the dominance of the most common words and increases the chances of picking less likely, more unusual words.
Making the output more creative.
Yeah.
Diverse. Maybe unexpected.
Precisely. Instead of just saying my favorite color is green, a high-temperature model might generate something poetic like, my favorite color is the deep emerald of a mossy forest floor after a spring rain.
Okay.
Yeah.
And low temperature.
If you turn the temperature down closer to 0, it sharpens the probability distribution. It makes the model stick much more closely to the most probable words. And if you set the temperature to exactly 0,
it always picks the single most likely word.
Always. It becomes completely deterministic. Same input, same output every single time, which is useful when you need absolute consistency and precision, not creativity.
Got it. So high temperature for brainstorming, low temperature for factual recall. That makes so much sense now why AI can be so creative, like mid-journey images or writing poetry, but also why it might just make things up or hallucinate.
Exactly. If it's sampling and a slightly wrong but plausible sounding word still has a non-zero probability, it might occasionally pick that word. And then it builds on that mistake, confidently generating a plausible but entirely false statement.
It's a feature and a bug rolled into one.
It's inherent in the design. And building on that, these models aren't just sticking to text anymore, are they? We're seeing the rise of multimodal AI.
Right. Handling more than just words, images, sounds.
Exactly. The core idea is extending these language models to incorporate more types of data, more modalities, beyond just text.
What does that look like in practice? What can they do now?
Well, models like GPT-4V and the latest Claude 3 can understand images alongside text. You can upload a photo and ask the AI questions about it.
Like a kind of dog is in this picture.
Or describe the scene, or even analyze the data in this chart image and tell me the key trends. Some advanced models are starting to understand video, 3D assets for gaming or design. Even complex scientific data like protein structures for drug discovery.
That vastly increases their usefulness, surely.
Massively. OpenAI themselves, in their 2023 notes about GPT-4V, called incorporating image inputs a key frontier in AI research. It just makes AI applicable to so many more real-world problems and naturally increases the demand for apps built on these richer, more world-aware models.
It raises a really important question, though. If these models can now see and maybe soon hear and interact with more types of information, how does that change their internal knowledge? Does it make them understand the world more deeply?
That's the big question researchers are exploring. Does interacting with images give it a better grounding in reality? It's moving beyond just manipulating symbols, words, to connecting those symbols to sensory input. It's a huge step towards AI that interacts with the world in a much richer, potentially more human-like way.
Okay, so we've peeked inside the AI's mind. We understand its probabilistic nature, how it learns. Now let's get practical. How do you, the user, actually steer these incredibly powerful systems? How do you get them to do what you want?
Right? From giving simple instructions to building these more complex agents that can act on their own.
And the starting point for almost everyone is prompt engineering, isn't it?
Absolutely. Prompt engineering is, hands down, the most common, the most accessible, and often the easiest way to adapt these big foundation models for your specific needs.
So what is it, fundamentally?
The basic idea is you're carefully crafting your instructions, the prompts, to guide the AI towards the exact outcome you want. And the key thing is you're doing this without changing the model's core programming. You're not rewriting its internal code or anything.
It's just like giving really good directions.
That's a perfect analogy. Imagine you're talking to this incredibly intelligent, super knowledgeable assistant who understands almost everything, but is also very literal. They need your precise guidance for each specific task. Your prompt is your direct line to controlling that intelligence.
Okay, let's unpack this, especially for someone listening who feels they have zero technical background. This is your most direct way to influence AI. You don't need to know algorithms or coding. You just need to communicate clearly.
Exactly. And one common technique is called in-context learning, or sometimes few-shot learning.
Sounds technical, but is it simple?
Very simple in practice. It just means giving the AI examples directly within your prompt to show it what you want. So if you want it to translate English to French, you could start your prompt with examples like English, hello French, bonjour, English, thank you French, merci.
And then you give it your actual request.
Right. Then you add English, how are you, French. And the AI, having seen the pattern from your examples, will likely complete it correctly with comment allez-vous, or similar. The more powerful models, like GPT-4, often need fewer examples, sometimes just one shot, or even none, zero shot, if the task is simple enough.
It's amazing how fast they pick up patterns. Now, you also mentioned a difference between a system prompt and a user prompt. Can you explain that?
Sure. Think of the system prompt as setting the stage. It gives the AI its overall role, its personality, or the general context for the conversation. You might tell it, you are a friendly and helpful travel agent specializing in budget trips to Southeast Asia.
Like giving it a job description.
Exactly. Then the user prompt is the specific question or task you give it within that role. Like, find me cheap flights to Bangkok in May.
Got it. And you mentioned there's a limit to how much info you can put in a prompt.
Yes, that's the context length or context window. It's the maximum amount of text, measured in words or tokens, the model can consider at one time. This limits how many examples or how much background info you can stuff into a single prompt before the model starts to forget the beginning. These windows are getting much bigger, but they're still finite.
Okay, so besides giving examples, what are some simple, practical tips anyone can use right now to write better prompts, to become a better prompt engineer?
Great question. There are definitely some best practices.
Lay them on us.
Okay, first, be clear and explicit. Don't be vague. If you need the output in a specific format, say so. Give me the answer as a numbered list, or extract the names and addresses only. The AI isn't a mind reader. Precision helps.
That makes sense. What else?
Second, ask the model to adopt a persona. This is super powerful. Tell it, act as an expert astrophysicist explaining black holes to a 5-year-old, or respond in the style of a pirate. This massively shapes the tone and complexity of the answer.
I like the pirate idea.
Okay.
Okay, third.
Provide sufficient context. Give it the background info it needs. If you want a summary of an article, paste the article in. If you're asking it to reply to an email, provide the original email text. Don't make it guess.
Got it. Give it the raw materials.
Fourth, decompose complex tasks. If you have a big multi-step request, break it down. Instead of write a business plan, ask it step by step. First, help me define my target market. Then, now let's outline the marketing strategy, guide it through the process.
Okay, break it down. Good advice for humans, too.
True. Fifth, use delimiters. This helps the AI distinguish your instructions from the content it needs to process. Use markers like triple quotes, angle brackets, or XML tags, text, around the text you want it to work on, like summarize the following article text here.
So it knows exactly what to focus on.
Exactly. And finally, sixth, specify the output format. If you need JSON or a table or bullet points, tell it explicitly. Format the output as a JSON object with key's name and email. This is crucial if you're feeding the AI's output into another program.
Those are fantastic, really concrete tips. It really boils down to being a good, clear communicator, doesn't it?
Pretty much, yes. Clear instructions get clear results.
But what about information that the AI just doesn't know? Stuff that happened after it was trained or private company data? Its knowledge has a cutoff date, right?
That's a critical limitation, absolutely. An AI model's core knowledge is static, frozen at the time its training data was collected. It doesn't know about last week's news or your company's latest sales figures or the contents of your personal documents.
So how do we bridge that gap? How does it access current or private info? This is where context construction comes in.
Exactly. Context construction is about dynamically providing the model with the information it needs at the time of the request.
How does that work?
The main technique here is called retrieval augmented generation, or RG. It sounds complex, but the idea is straightforward.
Okay, break down R key for us.
RI involves two steps. First, when you ask a question, the system retrieves relevant information from an external source. This could be a search engine for current events, your company's internal document database, your past conversation history, whatever.
So it goes and fetches relevant facts first.
Right. Then, second, it augments the original prompt by adding that retrieved information into the context window right alongside your question before sending it all to the main language model.
So you're basically saying, here's the question, and by the way, here's the relevant document you need to answer it.
Precisely. You're giving it the specific, up-to-date information it needs on the fly. This allows models to answer questions far beyond their original training data, making them vastly more useful for real-world tasks.
That's clever. So RAG deals with the static knowledge problem.
It does. It effectively gives the AI access to a dynamic, external, long-term memory to supplement its static internal knowledge and limited short-term memory, the context window. Your AI chatbot can now discuss your company's latest product, even if the model was trained years ago, because RAG fetches the new product info just in time.
That makes AI way more practical. Now, moving beyond prompts and RAG, we get into AI agents. This sounds even more capable, maybe even a bit sci-fi. What are they?
It's the next logical step, really. The core idea of an AI agent is a system that can do more than just passively respond. It can actively reason, plan a sequence of actions, and critically use external tools to accomplish complex, multi-step tasks.
Use tools? Like what?
Well, a RAG is actually a simple type of agent where the retrieval step uses a search or database lookup tool. But agents can use a whole suite of tools. Calculators, code interpreters to run Python scripts, web browsers to search the internet, APIs to interact with other software, basically anything that extends its capabilities beyond just language processing.
Can you give a concrete example? How would an agent tackle a problem?
Sure. The book uses a hypothetical Kitty Vogue example. Imagine you ask an agent, project the sales revenue for our Fruity Fedora product over the next 3 months.
Okay. A standard LLM might just guess, right?
Right. Or say it doesn't have sales data. But an agent would reason, okay, to project sales, I first need historical sales data for Fruity Fedoras. Step 1, reasoning.
Makes sense.
Then it would think, how do I get that data? And it would decide to use a tool, maybe in a SQL query generator, to craft a query for the company's sales database. Step 2, planning and tool selection.
It writes its own database query.
Potentially, yes, or calls a function that does. Then it would execute that query, using another tool, maybe a code interpreter, to get the numbers back. Step 3, tool use.
Okay, it has the data now.
Then it might analyze the data, maybe use another tool like a forecasting library or a calculator, generate the projection, and finally present the answer. It might even reflect, do I need more info? Maybe path marketing campaigns. And then decide to use a web search tool to find that. It's a loop. Reason, plan, act. Use tool, observe, reason.
Wow. So what this really means is AI is shifting from just generating content to actually doing things.
Yeah.
Interacting with systems, fetching data, performing actions. solving problems autonomously.
Exactly. It dramatically expands what AI applications can do. They can automate entire complex workflows, not just isolated little tasks.
That's incredibly powerful.
Mm.
But it also sounds potentially risky. More autonomy, more steps,
Hmm.
more ways for things to go wrong.
You've hit the nail on the head. While agents are incredibly powerful, they absolutely introduce new failure modes and significant security risks that need careful consideration.
How so?
Well, if an agent is designed to execute a sequence of actions, a failure at any single step can cascade. It can mess up everything that follows, making it much harder to debug than a simple one-step AI call. And the stakes get much, much higher when you give an agent right actions.
Right actions, meaning it can change things.
Yes. The ability to actually modify its environment, schedule a meeting in your calendar, send an email on your behalf, execute a stock trade, modify a database record. The book stresses that granting these capabilities requires utmost care,
I should hope so.
because the consequences of an error, sending the wrong email, booking the wrong flight, deleting the wrong data, can be severe. It's crucial to build in robust mechanisms for self-monitoring, reflection, and error correction. Agents need ways to check their own work, identify when something seems off, and ideally correct mistakes, or at least stop before causing damage.
So this raises a huge question, doesn't it? As these systems get more autonomous, more capable of acting in the world, how do we ensure they do so reliably, safely, ethically?
That is the central challenge defining the next phase of AI development and deployment. How do we build trust? How do we implement safeguards? How do we maintain meaningful human control? These are massive, open questions.
We've covered the models, how they think, how we guide them. But underlying all of this, the real fuel, the often unsung hero, is the data.
Absolutely fundamental. You can have the best model architecture, but without good data, it's useless.
And here's a surprising idea that kind of flips the script on common wisdom. When it comes to data for AI, especially for refining models, quality often beats sheer quantity.
That's a really crucial, maybe counterintuitive point. For years, the mantra in AI was just more data, more data, more data. And for training those huge foundational models from scratch, massive scale is still important.
But for making them better at specific tasks,
For that fine-tuning process, yes, the narrative changes significantly. Quality becomes king. For example, the folks who built the Yi models, a big open-source LLM family, they found that using just 10,000 really carefully crafted, high-quality instruction examples worked better for improving the model than using hundreds of thousands of noisy, lower-quality examples scraped together.
10,000 good examples beat hundreds of thousands of mediocre ones.
Exactly. And there's another study called LEMA, stands for Less is More for Alignment. They showed that a pretty big 65 billion parameter llama model, when fine-tuned with only 1,000 meticulously curated examples, produced answers that were comparable in quality to much larger models trained on vastly more data.
Just 1,000 examples.
Yep. It highlights this profound insight. The quality, the relevance, the precision of your data matters immensely more than just the volume, especially for task-specific tuning.
So what makes data high quality in this context?
It needs to be truly relevant to the task you want the AI to perform. It needs to be consistent in its formatting and style. It needs to be correctly labeled or aligned with your requirements. It should ideally be unique, avoiding too much repetition. And critically, it needs to be compliant with privacy rules, licensing, and ethical guidelines. It's not just about bulk. It's about thoughtful curation.
Okay, let's really unpack that. It flips that old more data is always better idea on its head. It's less about hoarding data and more about the craft involved in selecting and preparing it.
It really is like the difference between just dumping random ingredients in a pot versus a master chef carefully choosing and prepping a few perfect components for a gourmet dish.
Nice analogy. So if quality is paramount, where does this high-quality AI data actually come from? Where do developers get it?
Good question. There are a few main avenues. First, you can get it manually through human annotation.
People actually creating or labeling data by hand.
Exactly. Human experts meticulously labeling images, transcribing audio, writing examples, rating responses. This usually yields very high quality, precise data tailored to the task, but
It sounds expensive and slow.
extremely expensive and very slow, especially for complex tasks needing expert judgment. Imagine having doctors label medical images or lawyers annotate legal documents. It doesn't scale easily.
Okay, so manual annotation is one source. What else?
Second, you can use open source datasets. There are platforms like Hugging Face, Kaggle, various government data portals, university research sites. They host vast collections of datasets, often free to use.
That sounds promising. Free data.
It can be a fantastic resource. You get access to diverse, sometimes huge data sets, but you have to be careful. You need to rigorously check the quality. Is it clean? Is it actually relevant to your specific application? And critically, you need to check the licensing. Can you legally use this data for your commercial product? You can't just grab anything.
Right, licensing is key. So manual human data, open source data.
Right.
What's the third main source?
The third, and often the most valuable, especially for improving products already in use, is user-generated interactions.
Data from how people actually use the AI.
Exactly. It's a broad category. It includes content users create, like product reviews, forum posts, social media comments where your brand is mentioned. It includes system data, like what links people click on, what search terms they use, how they interact with features in your app. And it includes direct user feedback, thumbs up, thumbs down ratings on AI responses, written suggestions, bug reports.
Why is that the most valuable?
Because it directly reflects how real people use your product in the wild. It shows their preferences, their pain points, their actual needs. It allows the AI to adapt to real-world usage patterns, but
There's always a but.
it also comes with its own challenges. User data can be noisy, biased, sometimes irrelevant, sometimes even intentionally malicious, so it needs careful filtering and processing before it can be used effectively for training.
Okay, that makes sense. Now, here's a really intriguing, maybe slightly unnerving area. AI-generated data.
Oh.
The idea that AI can create its own training data.
Oh, yes, synthetic data. It's a huge topic.
It sounds revolutionary, right? Like AI pulling itself up by its own bootstraps, but also potentially problematic.
It's definitely a double-edged sword. The core idea is that AI itself can be used either to augment existing real data or to synthesize entirely new data from scratch.
Okay, what's the difference? Augmentation versus synthesis.
Data augmentation starts with existing real data and creates variations of it. A classic example is taking an image of a cat and then creating new training examples by flipping it horizontally, rotating it slightly, changing the brightness a bit. It's still based on a real cat image, but you get more data points. Another technique is adding controlled noise, slight distortions, which can actually make the model more robust to imperfect real-world input.
So augmentation expands on real data. What about synthesis?
Data synthesis generates data entirely from scratch, designed to mimic real data, but without a direct link to any specific real-world instance. This could be simulating realistic user behavior, like how a mouse might move across a web page, to train UI models, or generating fake but plausible financial transaction data based on patterns and templates to train fraud detection systems without using real private data, or even using one AI model to generate thousands of instruction response pairs to train another AI model.
The last one. Using AI to make data to train AI. That sounds incredibly powerful for scaling things up. What's the downside? What are the perils?
There are several significant limitations and real dangers. First, quality. AI-generated data, especially for complex tasks requiring deep reasoning or understanding subtle nuances, might just not be as good, as accurate, or as rich as high-quality human-generated data. It can be repetitive or lack common sense.
Okay, quality might suffer.
Second, imitation, not innovation. AI fundamentally learns by imitating patterns it has seen. It's great at interpolating within the data it knows, but it struggles to create truly novel, out-of-distribution data that goes beyond its training unless it gets significant human guidance. It can't invent something truly new from whole cloth.
It remixes but doesn't create truly original ideas.
Largely, yes, but the biggest concern, the one that researchers are really worried about, is model collapse.
Right. You mentioned this before. Explain model collapse again. Why is it so serious?
Model collapse, sometimes called the curse of recursion, is the fear that if we increasingly train new AI models predominantly on data generated by previous AI models, the quality will degrade over time. Because each generation of AI might amplify tiny errors or biases from the previous one. The models could start to forget the diversity and richness of the original human data they were ultimately based on. They might converge towards an average, bland, potentially inaccurate representation of reality. They learn the AI's version of the world, not the real world.
Like making photocopies of photocopies. Each one gets a bit worse.
That's a great analogy.
Right.
And there are real examples. That story about the Grok model from X, formerly Twitter, it apparently refused a request because it violated OpenAI's policies. Why? Because it was trained on so much web data that was already filled with ChatGPT's outputs, including its safety refusals. It was mimicking the safety layer of another model.
Wow. So it's not just theoretical.
No, and it's a very serious concern for the long-term future of AI progress. If we run out of fresh, high-quality human data and rely too heavily on AI-generated data, future models might become less capable, less creative, less connected to reality.
And there's another issue too, right, with tracking where data came from. Obscure lineage.
Yes, that's another major problem. When you mix real data with synthetic data and then use that to train a model that generates more data, it becomes incredibly difficult, maybe impossible, to trace the lineage. Where did this piece of information originally come from? Is it based on fact or an AI hallucination from 3 generations ago? This has huge implications for privacy, intellectual property, and just basic factual verification.
So connecting this to the bigger picture, this balance between using synthetic data for scale and efficiency versus the risk of model collapse and losing touch with reality, it feels like a fundamental challenge.
It absolutely is. Finding the right balance, ensuring a continuous feed of fresh, diverse, high-quality human data, and developing techniques to detect and mitigate the negative effects of synthetic data. These are critical research areas. How we manage this could genuinely shape the limits of AI progress in the coming years.
Okay, so we've got our model. Maybe we've fine-tuned it with high-quality data, maybe even some carefully generated synthetic data. Now, the ultimate test. How do we actually know if it's good? How do we evaluate its performance?
Right. And the core idea here, which might surprise people, is that evaluating these big, powerful foundation models is much, much harder than evaluating older, traditional machine learning models.
Harder, why? Don't you just check if the answer is right?
If only it were that simple. With traditional ML, tasks were often close-ended, like classifying an email. It's either spam or it's not spam. There's a clear right answer, a ground truth to compare against. You can easily calculate accuracy.
Okay, simple, right or wrong.
But with foundation models, they're designed for open-ended generation. Ask it to summarize a book, or write a poem, or explain a complex topic. There isn't just one right answer. There could be dozens, hundreds of perfectly valid, high-quality responses.
So comparing against a single ground truth doesn't work anymore.
Exactly. How do you objectively score a poem? Or definitively say, this summary of a book is better than that one? To really validate that book summary, you'd have to read the whole book yourself, form your own understanding, and then subjectively compare it to the AI's version. That's incredibly time-consuming, requires expertise, and it's highly subjective. It just doesn't scale.
And this difficulty, it affects those standard tests, the benchmarks, right?
It does. Because models improve so quickly on these open-ended tasks, benchmarks designed to measure their capabilities become saturated really fast. A benchmark that was challenging a year ago might now be easily aced by all the top models, making it useless for telling them apart. GLUE, a big language understanding benchmark, got saturated in about a year. They had to create a much harder version, Super GLUE. It's a constant arms race.
So what this all means is just figuring out if an AI app is genuinely useful, reliable, safe. It's a massive challenge, way more complex than just looking at an accuracy score. It's often overlooked, isn't it?
Hugely overlooked, but absolutely critical. If you can't reliably evaluate your AI, how can you improve it? How can you trust it?
So if objective benchmarks are tricky and having humans evaluate everything is too slow and expensive, who or what are the judges of AI performance then?
This brings us to a really interesting and evolving area, the judges of AI. It boils down to a trade-off between humans and AI models themselves.
Humans versus AI judges.
Right. Human evaluation is still considered the gold standard, especially for those subtle, nuanced qualities that are hard to measure automatically. Things like, is the answer factually consistent? Is it safe and harmless? Does it exhibit the right personality or tone for role-playing? Does it show common sense? Humans are good at judging that.
But as you said, slow, expensive, and subjective.
Exactly. It's a major bottleneck, which is why, increasingly, AI models themselves are being used as judges to try and automate and speed up the evaluation process.
An AI judging another AI, that sounds recursive, like the data problem again.
It has echoes of that, yes, and it comes with its own set of challenges. But the appeal is obvious. Speed and cost.
So how does an AI judge actually work? What can it do?
You can design prompts for an AI judge to perform various kinds of evaluation. You could ask it to rate the relevance of a generated answer on a scale of 1 to 5. You could give it 2 different answers to the same question and ask it to choose which one is better. You could even ask it to check for specific stylistic things, like, does this response sound like it was written by Gandalf? If that's the persona you're aiming for.
Okay, so you're prompting an AI to critique another AI's output.
Essentially, yes, and it's becoming widespread. LangChain, a popular AI development framework, reported back in 2023 that something like 58%, nearly two-thirds of all the evaluations being done on their platform were being performed by AI judges.
58%, that's huge. But surely, using an AI as a judge must have its own biases, its own problems. It can't be perfect.
Absolutely not perfect. You're right to be skeptical. There are significant known challenges and biases. First, inconsistency. Because AI models are probabilistic, the same AI judge might give slightly different scores if you run it twice on the same input or if you phrase the evaluation prompt slightly differently.
Okay, inconsistency. What else?
Self-bias. This is a big one. Models tend to prefer their own outputs or outputs from models in the same family. Studies showed GPT-4 gave itself about a 10% higher win rate when judging against other models. An older version of Claude showed a 25% self-preference.
Wow, they like their own cooking.
Apparently so. Then there's position bias. Sometimes the judge unfairly favors the first answer it sees in a list, or maybe the last one, just because of its position.
Like humans skimming a list.
Kind of. And finally, leniency or length bias. Some AI judges might tend to rate longer answers more highly, even if they're less accurate or more rambling, or they might just be generally too easy or too harsh in their scoring.
So it's definitely not a magic bullet. Are there ways to mitigate these biases?
People are actively working on it. It's a big research area. For instance, one study by Zhang and others in 2023 found that if you include specific examples of how to evaluate within the prompt you give the AI judge, it can make its judgment significantly more consistent. Randomizing the order of the responses being compared also helps counteract position bias.
So it's a tool, but one you have to use very carefully, knowing its limitations.
Exactly. What's really fascinating here is this inherent tension. We desperately need automated, scalable evaluation to keep up with AI development. But the very tools we're using for automation, the AI judges have their own complex biases and limitations that we're still trying to fully understand and overcome.
Right. So beyond just getting a score, how do we define what good enough actually means for an AI application? It feels like it's not always about pure factual correctness, but more about, is it useful? Does it do the job?
That's a crucial distinction. Defining good is complex and highly context-dependent. It's rarely just about being correct in a simple sense. It's much more about being useful for the intended purpose and being properly aligned with human intent and values.
So what kinds of criteria fall under that umbrella?
We look at several things. First, functional correctness. Does the app actually achieve its goal? For something like AI generating code, you can automate checks. Does the code compile? Does it pass tests? Metrics like pass at K measure this. But for open-ended text, it's much harder to automate functional checks.
Okay, does it work? What else?
Semantic similarity. This is important. Does the AI's answer mean the same thing as a known good answer, even if it uses different words? AI is great at paraphrasing, so simple text matching isn't enough. You need to check if the core meaning is preserved.
Right, meaning over exact words.
Then there's safety. This is non-negotiable for most applications. You need robust systems to track and prevent the AI from generating harmful content. Hate speech, harassment, promoting illegal acts, self-harm content, leaking private information.
Safety is paramount. And the big one, factual consistency. You mentioned hallucinations earlier. How big a problem is this, really?
It is arguably the single biggest hurdle to widespread trust and adoption, especially for information-sensitive applications. AI models can and do hallucinate. They generate plausible-sounding but completely false information, and they deliver it with absolute confidence.
We've all seen headlines.
We have. Tragic cases like AI chatbots reportedly giving harmful advice, lawyers getting sanctioned for submitting AI-hallucinated legal precedents to courts, major companies like Air Canada being forced to honor false information given out by their chatbot because the customer relied on it.
So it's not just funny errors. It has real-world consequences.
Serious consequences. This phenomenon, sometimes called self-delusion in models where the AI treats its own fabrications as facts, is deeply problematic.
How are people trying to fix it?
There are approaches. Self-verification, where the model generates multiple possible answers or lines of reasoning and then checks them against each other for consistency. Or knowledge-augmented verification, which is related to ARA. The model actively uses external tools like web search or trusted databases to try and verify its own statements before outputting them. But it's an ongoing, incredibly difficult challenge. No perfect solution exists yet.
So what this all means for us is that quality control for AI is incredibly hard, incredibly important, and without it, the risks can easily outweigh the benefits in many cases. It sounds like evaluation needs to be built into the development process from the start.
Absolutely. The idea of evaluation-driven development is key. You need to constantly test and evaluate throughout the entire life cycle.
Which brings us to one more evaluation method,
Mm.
comparative evaluation. Instead of scores, just comparing outputs.
Right. Instead of trying to give an absolute score, this answer is a 4 out of 5, you simply present two different outputs, maybe from two different models or two versions of the same model, and ask a judge, human or AI, which one is better.
And this is what powers things like the Chatbot Arena leaderboard, when people vote.
Exactly. LMSYS's Chatbot Arena is a prime example. Even ChatGPT itself often asks users to compare two responses side by side and pick the preferred one.
What are the advantages of just saying, this one's better?
The main advantages are it tends to capture nuanced human preference quite well, often better than arbitrary scoring scales. It's harder for benchmarks to get saturated because there's almost always a subjective better, even if both answers are good. And it's generally harder for developers to game the system by just optimizing for one specific numerical metric.
But surely it has downsides too, relying on subjective preference.
Oh, definitely. Users might prefer an answer that's more polite or entertaining, even if it's less factually accurate. You could get malicious users deliberately choosing bad answers to sabotage the rankings. The prompts people use in these public arenas might not reflect complex real-world use cases. Apparently, hello is a huge percentage of prompts on Chatbot Arena, which doesn't test much. And crucially, the user judging the responses might not actually know the correct answer to the question they asked, but they're still picking which AI they liked better.
So that raises a really important final question on evaluation. How do you balance capturing broad user preference, which comparison does well, with the need for objective accuracy, safety, and specific task requirements?
That is the million-dollar question in AI evaluation right now. There's no single answer. It likely requires a combination of methods. Automated checks for safety and specific functional correctness, AI judges for scalable comparison on subjective qualities, human experts for gold standard evaluation on critical or nuanced tasks, and careful analysis of real user feedback. It's about building a multifaceted evaluation strategy, not relying on any single approach.
Okay, we've journeyed through how AI works, how we guide it, the crucial role of data, and the tricky business of evaluation. Now let's talk about taking one of those powerful general-purpose AI models and really making it yours, customizing it for specific needs, and then making sure it runs fast and efficiently enough for the real world.
Right. This brings us to fine-tuning and optimization.
Let's start with fine-tuning. What is it, fundamentally?
Fine-tuning is a core technique in AI engineering. The basic idea is you take a pre-trained foundation model, one of those massive ones we talked about, and you adapt it further by slightly adjusting its internal weights or parameters.
With those billions of numbers inside the AI's brain.
Exactly. Think of them as the connections between neurons. By tweaking these connections based on new, specific data, you can nudge the model to become better suited for a particular task, or to adopt a certain style, or to follow specific safety rules more reliably.
So it's like giving an expert a specialized top-up course.
That's a great way to put it. Chip Huyen, in her book, suggests thinking of fine-tuning as unlocking the capabilities a model already has, but that are difficult for users to access via prompting alone. The potential is already there. Fine-tuning just makes it easier to bring out for specific purposes.
What kinds of specific improvements can you get from fine-tuning?
You can significantly boost performance on domain-specific tasks. Make a general model much better at, say, writing Python code, or answering tricky medical questions accurately, or understanding complex financial jargon. You can also use it to strengthen safety guardrails, making it much less likely to generate harmful or biased content. And it's excellent for enforcing specific output styles or formats consistently, like always generating valid JSON or maintaining a consistent brand voice.
That sounds incredibly useful. What's the catch? What does it require compared to just prompting?
The main trade-off is resources. While fine-tuning is usually way less computationally expensive than training a foundation model from scratch, it still generally requires more resources than just prompt engineering. You need a good data set, high-quality examples of the specific behavior you want to teach the model, and you typically need more specialized expertise and computing power than just writing prompts.
Okay, so traditionally, more resources needed. But here's where it gets really exciting for listeners, right? There are ways to do this much more efficiently now. You don't necessarily need a supercomputer anymore.
Exactly. This has been a huge breakthrough area. It's thanks to techniques broadly called parameter-efficient fine-tuning, or PET. And the most popular and impactful method within PET right now is LoRa.
LoRa low-rank adaptation. How does that make fine-tuning so much more accessible?
The genius of PFT methods like LoRa is that instead of needing to update all of the model's billions of parameters, which requires massive amounts of memory and processing power, they find clever ways to achieve similar results by only modifying a very small number of parameters.
How small are we talking?
Tiny, relatively speaking. LoRa, for instance, works by injecting small, low-rank matrices into the existing model layers and only training those small matrices. It doesn't touch the original giant model weights. The result is dramatic. For example, a LoRa adapter, the small set of trained parameters for a big model like Llama 213B, might only be around 6 or 7 megabytes.
Megabytes. Compared to the full model being how big?
The full Llama 213B model is about 26 gigabytes, so you're talking about a tiny fraction of the size.
That's incredible. From gigabytes down to megabytes for the customized part.
It's a total game changer for accessibility. It means you can often perform effective fine-tuning on a single good consumer GPU, maybe even a high-end laptop CPU in some cases, instead of needing racks of servers in a data center.
That really opens the door for individuals, researchers, smaller companies to customize these powerful models. Makes AI truly your AI.
It absolutely does. And there's another related cool technique called model merging.
Merging models, like combining different AI brains.
Sort of. The idea is you can take different models that have been fine-tuned for different skills, say one is great at creative writing, another is great at coding, and you can mathematically merge their parameters, or their LoRa adapters, to create a new single model that hopefully inherits capabilities from both.
Combining skills without retraining everything.
Exactly. And often these merging techniques can be done relatively cheaply, sometimes even without powerful GPUs, making it even more accessible for experimentation by independent developers. These techniques, PFT, LoRa, merging, are really democratizing the ability to build specialized AI.
Okay, so we've built our model. We've maybe fine-tuned it efficiently using LoRa. Now, it needs to run in the real world. This is to be fast and cheap, right? This is where inference optimization comes in.
Absolutely critical. A super smart AI that takes minutes to answer a question is basically useless for most applications, especially interactive ones like chatbots. So after the model is trained and fine-tuned, there's a whole field dedicated to making it run quickly and cost-effectively during inference, which is the process of actually using the model to generate outputs.
This is why the AI in my app feels instant, even though the model behind it is huge.
That's the goal of inference optimization, yes, making it feel seamless.
So, when we talk about speed here, what are the key things engineers measure? What makes an AI feel fast?
For interactive applications, there are usually two main latency metrics people care about. First is time to first token.
TTFT.
How long till the first word appears?
Exactly. From the moment you hit send on your query, how long does it take for the AI to start spitting out its response? For a chatbot, if this takes too long, the conversation feels dead, unresponsive. You want this to be very quick, ideally under a second.
Okay, TTFT needs to be low. What's the second metric? Time per output token, TPOT. Once it starts generating, how fast do the subsequent words or tokens appear?
The streaming speed.
Right. You want this to be fast enough that it feels like smooth streaming, ideally faster than typical human reading speed, which is maybe around 6 to 8 tokens per second. If it generates too slowly, word by word, it's frustrating.
Got it. Fast start, then fast streaming. And for handling many users.
That's throughput, how many requests the system can handle per second overall, critical for scaling up.
So how do engineers make these massive models achieve low TTFT and high TPOT without just making the model dumber or smaller?
One of the most powerful techniques is quantization.
Quantization, reducing precision.
Exactly. Remember how models store their parameters as numbers? Usually these are high precision numbers, like 32-bit floating point. Quantization reduces the precision, converting those numbers to 16-bit or 8-bit or even 4-bit formats.
Like saving a high-res photo as a slightly lower-res JPEG.
That's a great analogy. It makes the model file much smaller, meaning it takes up less memory, which is often a huge bottleneck, especially on devices like phones. And calculations with lower precision numbers are much faster for the computer hardware to perform.
But doesn't reducing precision hurt the quality of the answers?
Surprisingly often, the impact on quality is minimal, sometimes even negligible, especially when going from 32-bit down to 16-bit or 8-bit. Even 4-bit quantization can work remarkably well for many models with clever techniques. It's a trade-off, but the speed and memory gains are often huge. Companies like Apple heavily use quantization, like 2-bit and 4-bit mixtures, to run AI effectively on iPhones. NVIDIA's latest GPUs even have specific hardware acceleration for 4-bit math, showing how important this is.
Wow, so quantization is key. Are there other tricks for speed, especially for language models that generate word by word?
Yes, because generating one token at a time sequentially is still inherently slow for very long outputs. So people have developed clever techniques. One is speculative decoding.
Speculative, sounds like guessing.
Kind of. The idea is you use a much smaller, faster draft model to quickly predict a whole chunk of tokens, say, the next 5 words. Then, the main, large, powerful model checks that draft chunk all at once. If the draft was good, you just accepted 5 tokens very quickly. If the draft was wrong at some point, the main model corrects it and takes over, generating token by token from there. It's a way to sometimes leap ahead.
Clever. Getting multiple tokens for the price of one check.
Exactly. Another area is parallel decoding, trying to find ways to generate multiple tokens truly simultaneously where the model structure allows, rather than strictly one after another. These are complex, cutting-edge techniques, but they all aim to shave off those crucial milliseconds and seconds to make the AI feel responsive.
So connecting this back to the big picture,
Yeah.
all these optimization techniques, quantization, speculative decoding, they're not just technical tweaks, they're what actually makes AI practical.
Right.
What moves it from a research curiosity to a scalable, affordable service we can all use daily.
Absolutely. Without inference optimization, even the most brilliant AI model would be too slow, too expensive, too power-hungry for widespread use. Optimization is the bridge between capability and usability. It's about finding that sweet spot balancing speed, cost, and quality to make AI integrate seamlessly and effectively into our products and our lives. Hashtag outro.
Wow. What an incredible journey we've taken today on this deep insight dialogue. We started with that AI explosion, how it suddenly felt like it was everywhere, and how foundation models and that model as a service idea made powerful AI so much more accessible.
Right, lowering that barrier to entry dramatically.
Then we went inside the AI's mind, simplifying how it works probabilistically, predicting the next word, and how that temperature knob controls creativity versus consistency.
Understanding that probabilistic core is key to understanding both its strengths and weaknesses.
From there, we got practical, exploring how you can guide AI with clear prompt engineering, even without coding, and how those smart agents take things further, using tools to actually do things in the world, not just talk.
Moving from generation to action.
We then shone a light on the unsung hero data, highlighting that crucial insight that quality often trumps quantity, especially for fine-tuning, and discussing that very real looming concern of model collapse if we rely too much on AI-generated data.
The data dilemma is fundamental.
And finally, we wrestled with the huge challenge of evaluation. What does good even mean for an open-ended AI? The limits of benchmarks, the pros and cons of AI judges, and the importance of safety and factual consistency.
Evaluation is perhaps the hardest but most critical piece of the puzzle right now.
So what does this all really mean for you listening?
I think it means that AI engineering, while complex under the hood, is this fascinating dance. It's a blend of powerful models, incredibly important data considerations, and clever optimization. And the crucial takeaway is, it's not just for the super specialized experts anymore. It's a field that's just brimming with opportunities for anyone who takes the time to understand how these key pieces, the models, the data, the prompting, the evaluation, the optimization fit together. You don't need to be a hardcore coder or data scientist to grasp the core concepts driving this revolution.
Exactly. And just having that understanding equips you to navigate this space, whether you're just curious or thinking about how AI applies to your work or even your life.
And while we've covered incredible progress today, it's important to remember the future still holds some fundamental challenges, big ones. We touched on scaling bottlenecks, things like the sheer amount of electricity needed to power these massive AI data centers. That's becoming a real global concern.
Competing with other energy needs.
Potentially, yes. And that risk of model collapse. We discussed the worry about running out of diverse, high-quality human data and having AI learn from increasingly degraded AI outputs. That's a serious long-term question about the sustainability of progress itself.
So that leaves us with a final provocative thought for you to mull over.
How might these very real practical limits, the limits of resources like electricity, the limits imposed by data quality, and the risk of collapse, how might these shape the kinds of AI applications we actually see developed and deployed successfully over the next decade? Will we see a shift towards smaller, more efficient models? Will the focus pivot even more heavily towards data curation and verification? Understanding the landscape we've discussed today equips you not just to be a passive observer of this future, but maybe, just maybe, to have a hand in shaping it.